Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0117, indicates that there is a low voltage signal from the Engine Coolant Temperature, ECT sensor 1 in the 2017 to 2022 Honda CRV. The ECT sensor plays a crucial role in providing real-time data about the engine's coolant temperature to the Powertrain Control Module, PCM, which is essential for optimizing engine performance and fuel efficiency. If the PCM does not receive accurate signals from the ECT sensor, it can lead to suboptimal fuel injection and timing adjustments, negatively impacting engine operation. The ECT sensor 1 is typically located near the engine block, allowing it to measure coolant temperature effectively. When a low voltage condition is detected, it is critical to conduct a series of diagnostic steps to identify the underlying cause, ensuring the vehicle operates within designed parameters. Properly diagnosing this code could save time and prevent unnecessary replacement of components. The ECT Sensor 1 is a vital component in the Honda CRV's engine management system. Its primary function is to measure the temperature of the engine coolant and relay that information to the PCM. This data is essential for calculating the correct fuel mixture and ignition timing, ensuring optimal engine performance. These sensors are usually positioned near the engine block, allowing for accurate readings of the coolant temperature. When the ECT sensor malfunctions and signals low voltage, the PCM may not adjust engine parameters correctly. This can lead to increased emissions, poor fuel economy, and potential engine overheating if not addressed promptly. Understanding the role and location of this sensor is fundamental to troubleshooting the P0117 code effectively. Several potential causes can lead to the P0117 DTC in your Honda CRV. The most common reason is a faulty ECT sensor, which may fail to provide accurate voltage readings. Poor connections, such as corroded terminals or loose wiring, can disrupt the signal sent to the PCM, resulting in erroneous data being processed. Additionally, there may be issues with the wiring itself, specifically a short in the TW wire between the ECT sensor and the PCM. Each of these issues must be meticulously examined and diagnosed to resolve the DTC. Addressing these causes ensures that the coolant temperature data is efficiently communicated to the PCM, maintaining the vehicle's operational integrity. Symptoms associated with the DTC P0117 can significantly impact vehicle performance. One of the most critical signs is engine overheating, which can result from incorrect coolant temperature readings affecting engine management. Drivers may also experience increased fuel consumption, as improper fuel mixture calculations can lead to less efficient combustion. Furthermore, drivers may notice overall poor engine performance, including hesitation or rough idling. Recognizing these symptoms early on is vital for preventing more serious damage to the vehicle. If these symptoms present themselves along with the P0117 DTC, an immediate investigation into the ECT sensor and related systems is necessary. In the first step of troubleshooting the DTC P0117, it is essential to turn the vehicle ignition to the on position without starting the engine. This allows for the use of the Honda Diagnostic System, HDS, to analyze data from the vehicle's subsystems. The ECT Sensor 1 should be checked to ensure that it is reading less than 0.08 volts. If this value is confirmed, it indicates that the failure has indeed duplicated, prompting the technician to proceed to the next diagnostic step. Conversely, if the value does not meet this threshold, it suggests that the system may be functioning intermittently. In this case, A thorough examination for poor connections or loose terminals at the ECT sensor and the PCM is recommended. Documenting and analyzing this data is crucial for effective troubleshooting. The second troubleshooting step requires turning the vehicle ignition off and disconnecting the ECT sensor 1-2P connector. Once the connector is removed, the ignition should be switched back to the on position while using the HDS to monitor the ECT sensor values again. As before, the technician should confirm that the values are less than 0.08 volts. If the readings are consistent with this threshold, the next step in the troubleshooting process should commence. However, if the values exceed this figure, it indicates that the ECT sensor itself may be malfunctioning and require replacement. This step emphasizes the importance of isolating the sensor to determine if the issue lies within the sensor or elsewhere in the vehicle's wiring system. In the third step of the troubleshooting process, the technician should again turn the vehicle ignition to the off position. Subsequently, the SCS line is to be jumped using the HDS, and it is important to wait for at least a minute to ensure proper system reset. After this period, the technician should disconnect the PCM connector, B51P, to facilitate the continuity test. With the ECT sensor connector and PCM connector both disconnected, continuity should be checked between the ECT sensor connector terminal number 2 and body ground. If there is continuity, it indicates a short circuit in the TW wire connecting the ECT sensor and the PCM. Immediate repairs to this shorted wire are necessary. If no continuity is detected, this suggests the TW wire is functional, thus requiring further investigation into other potential causes, or even substituting with a known good PCM. After completing the necessary repairs related to the DTC P0117, it's critical to conduct a final verification to ensure the fault has been resolved. The ECT sensor voltage should be rechecked using the HDS while the vehicle is in the on position with the engine at operating temperature. The readings should now be within the acceptable range. In addition to voltage checks, it is crucial to assess the overall vehicle performance to verify that the engine operates correctly without any overheating, erratic idling, or high fuel consumption. Completing a test drive can also help confirm that all systems are functioning as intended. Adequate verification ensures that the repair is effective and prevents recurrences of the issue. Preventive maintenance is integral to ensuring the longevity of the ECT sensor and associated systems in the Honda CRV. Regular inspections of electrical connections and wiring to the ECT sensor can help identify issues before they lead to failure. This includes checking for corrosion, loose fittings, or damaged wiring that could interfere with sensor operation. Additionally, being proactive in replacing components showing signs of wear can prevent more extensive damage down the line. Timely service not only enhances vehicle performance, but also helps maintain safety and reliability. A culture of preventive maintenance can ultimately save time, money, and unnecessary stress for vehicle owners. In conclusion, understanding the function of the ECT sensor in your Honda CRV is crucial to addressing the DTC P0117 effectively. Following the outlined troubleshooting steps systematically helps pinpoint the source of the problem, whether it be a faulty sensor, poor connections, or wiring issues. Proper diagnostic procedures ensure a well-functioning engine management system, optimizing both performance and fuel efficiency. Continued emphasis on preventive maintenance plays a key role in avoiding future issues, keeping your vehicle in optimal condition. By following these guidelines, you can ensure that your Honda CRV runs smoothly and efficiently, safeguarding both performance and investment. Please like and subscribe to the channel. See you next time.